Okay. All right, let's get our notes out. We have been talking about, or I've been talking about, doing these inequalities for a long time. I do have some papers to hand back or quizzes and stuff. I'll try to stop in time to do that. But I want to get to these inequalities because we've been talking about it forever. So, looking forward to it. So I in the notes, it says topic 3.10 part 2. And I'm going to look at example 1. He has graphed a beautiful little sine curve there for you. And he's actually graphed 2 periods of it. So there we go, a nice little sine curve. He's got it all there for you. For what values of x, or what are the values of x, for which the function is less than or equal to 0? Well, this is easy. If you have that graph, this is easy. The function, those are your y values. Where are the y's less than or equal to 0? Well, here is where it equals 0. Would you agree? Those are called the zeros. And if we want it less than, we would be looking at this. Would you agree? So what are the answers? They're intervals. This is an inequality. So, well, don't forget about this guy. So we'd have to say, let me double check my directions. Yeah. Negative 2 pi and 2 pi are both included. So one answer would be negative 2 pi. Agreed? He's blue. And then we would have, I'll put a union sign. And then we would have what? Negative pi to 0. And then we would have pi to 0. Now, I want you to think about that, because the graph is great, but you can also do a problem like this on the unit circle. If I said I need sine to be less than or equal to 0, where does that happen on the unit circle? That your sine is less than or equal to 0? Isn't that down here? Wouldn't that be pi to 2 pi? And if we're going negative, wouldn't it be 0 to negative pi? Or negative pi to 0 when I wrote the interval? So you can actually use the unit circle, and that's what he has you do on the next one. It says, where is the sine greater than or equal to root 2 over 2? Well, where does the sine equal root 2 over 2? At pi over 4 and 3 pi over 4, at least in the first revolution. 0 to 2 pi, that's where it equals. Now, where is it bigger than that? Isn't it bigger than that here? This is root 2 over 2 right here. This is where the y value is root 2 over 2. Isn't the y value going to be bigger than that on this top half or top piece of the circle? So what is the answer? Pi over 4 to 3 pi over 4? Now I need to check my directions. Oh, this time I am only going from 0 to 2 pi, so I'm done. because that is 0 to 2 pi once around the circle. That seems pretty easy, doesn't it? Let's look at example 3. Let f of x be less than g of x. Okay, so 0 to 2 pi, and f of x is 4 plus 2 cosine, and g of x is 3. What?
So we should probably subtract
I
that.
think that's probably a great idea. Actually, I'll move that 4 over there, so 2 cosine will be less than -1. Which means cosine is less than -1/2. Now you've got 2 options here, and it doesn't make any difference how you do it. You could sketch a cosine curve, just like he did in his first example. Just a straight up, regular old cosine curve. And somewhere on there, y's are -1/2. So here and here is where they're equal to -1/2. And then I want it less than. So on the cosine curve, would you agree that purple pinky part there would be the answer? I haven't figured out what those numbers are yet, but I could do it that way. You could also use your unit circle. Where is the cosine -1/2? Over here and over here, right? And what did you say that was? 2 pi over 3 and 4 pi over 3. Now remember, you're doing cosine. Cosines are x's. Here is where x is -1/2. Where is it less than -1/2? It's x's now, so I'm going left and right. Isn't this where the x's are less than -1/2? So the answer would be everything between 2 pi over 3 and 4 pi over 3. And it's a less than, so I use open intervals, because even though I color those in, they're really open. Is that okay? Yeah, not bad at all. All right, would you try example 4 on your own with your partner, see if you guys can get the same answer? We want h to be bigger than k. So we want 3 cosine to be bigger than √3 plus cosine. And it's still just 0. Ooh, and he's included 2 pi this time. Got to be careful how you write your answer to this. Keep in mind that whatever you write has to fit that, And it has to make sense in terms of the numbers. Like, it wouldn't make any sense to write this. That doesn't make any sense, because when you write an interval, it has to be little to big. Okay? So, I've got my unit circle drawn here. Well, first of all, did everybody get this? Cosine greater than root 3 over 2? Okay. If you're using a unit circle, would you agree this is where x is root 3 over 2, cosine is x, and that's where x would be bigger than that? Now, if I'm using my trusty curve, the answer makes more sense. You can get the answer from there and it's fine. But if you use your curve, here is where the cosine is root 3 over 2. Here is where it is bigger than root 3 over 2. On the circle, those two parts are connected, and that's what makes it a little confusing. What did you settle on as your answer to this question? 0 to pi over 6, or 7 pi over 6 to 2 pi. He included 2 pi this time. So that would be your answer. Oh, that's not 7 pi over 6, that's 13 pi over 6. Kooky. 11 pi over 6. Oh my gosh. What is wrong with me? I don't know. Is it right now? That would be over here.
Don't sweat.
That would be 11 pi, and that would be 1 pi. Okay. All right. Everybody okay? That's the final answer then? Okay. Now we're going to get a little bit more complicated. Take a look at example 5. Now we have a quadratic situation. All right, and we're still, and he's including 2 pi here, so we'll pay attention to that. All right, so tell me what you think we ought to do to get started on this.
We should factor.
We should factor. Absolutely, we should factor. And when we factor, we're going to get sine and then 2 sine plus 1.
We should have set those both equals here.
So my key values are going to be where the sine is 0 and where the sine is negative 1/2. Okay? So I want you to think about this for a second. Here's my sine curve. It's 0 here, there's open dots here, here, and here. Would you agree with that? That's where the sine is 0. Now, let's see if I can get this one right. Where is the sine negative 1/2? Well, that would be right here. And right here. Would you agree with that? And those values would be sine negative. Is that one 7 pi over 6? And 11 pi over 6. So I have labeled little open circles here. all of the kind of key points. Now, here's where you have to remember that this is a multiplication problem. If you are going to multiply these two things together, and they're going to be negative, then what can you tell me about the two things I'm multiplying? One is positive and one is negative. So either the sign is bigger than 0 and less than -1/2. Think of setting this less than 0, so it'd be less than. Or the sign is less than 0 and the sign is bigger than -1/2. This is your positive times your negative, and this is your negative times your positive, and it could be either one. Right? Okay, so let's look at our graph. If I'm doing the first one, and I'm doing this one in blue, just up here. If I'm doing the first one, then the sign has to be bigger than 0. So wouldn't that be just this part right here? But at the same time, the sign has to be less than -1/2. Well, wouldn't that be this right here? Is that possible? Anything blue and red? Gotta do both. And there are no numbers that that's gonna work for. So that case doesn't work. All right, what about the other one? What if I want my sign to be less than 0? So that would be this right here. Everybody with me? That's where my sign is negative. And at the same time, I need the sign to be bigger than -1/2. So wouldn't that be all of this and that right there? Here's -1/2. Bigger than. Well, where does that happen? You gotta be both. Blue and pink. Where am I blue and pink? This little piece right here. Now it could be this point, but this is not an or equal to, so that point doesn't count this time. Everything in between here is gonna count. Well, what interval is that? From here to here is what interval? Pi to 7 pi over 6. And then everything over here, which is 11 pi over 6 to 2 pi. What, Xander? You don't know what just happened?
Yeah, now I'm kind of confused on just the sign greater than, and then that one you flipped it.
Because somebody told me that if I'm gonna multiply two things together and it's gonna end up negative, then the two things I'm multiplying are either first one positive, second one negative, or first one negative, second one positive.
Okay, yep, that makes sense.
Now, if this had been a greater than 0, all of the numbers and everything on the number line would stay the same. But if it was greater than 0, then I would have positive, positive, negative, negative. These are so fun. All right, let's try the next one. Let's try example 6. plus cosine minus 1 greater than or equal to 0. Okay, what do you think? How do you think we're going to start? Be careful. Be careful. Guys, what kind of equation is that? Look at it carefully. That's the same as 2x squared plus x minus 1. Don't move that 1. Don't try to factor out a GCF. There is none. What do? It's a quadratic trinomial. We factor it like this, don't we? If you're struggling because of the cosines to get it factored, think of it literally as 2x squared plus x minus 1. That's what you got. Your variable is cosine theta, but treat it like an x. Well, how would that factor? Is that how it factors?
Could be.
Okay, so for our problem, that's 2 cosine minus 1 and cosine plus 1. Which means that cosine equals a half, or cosine equals -1. So I'm just going to come over to my graph now. I'm going to do this one in blue and this one in pink. Where is the cosine a half? Here and here. Let's see, a half is √3 and 5 pi over 3. I mean, pi over 3 and 5 pi over 3. So I'm going to come over here and in blue, here's pi over 3. And here's 5 pi over 3. And that makes perfectly good sense because that's where the cosine is a half. Now, where is the cosine -1? Pi. That's it. This is an or equal to problem, so I'm going to go ahead and color in those dots. And not only that, but it's a greater than problem. Which means, we just talked about it. What does that mean? If I'm multiplying two things together and it's greater than, then these are either both greater thans, so cosine greater than or equal to a half, and cosine greater than or equal to -1, or cosine less than a half and cosine less than or equal to -1. Okay, does that make sense to everybody? Okay, so now here's where we gotta pay attention to what's going on. So if I do this in blue, where is cosine bigger than or equal to a half? Would you say here and here? And at the same time, I need cosine to be bigger than or equal to -1. Well, isn't that the entire curve? Right? So if I'm not going to color it because I'm just going to erase it in a minute, but the whole thing would be colored in pink. So where's the overlap? What is the answer to that problem? 0 to pi over 3, or 5 pi over 3 to 2 pi. Does that make sense to everybody? I'm not done. I've done half the problem. Now I gotta turn around and figure out where is the cosine less than a half. Well, wouldn't that be this part right here? And at the same time, I have to be less than or equal to -1. Well, I can't be less than -1, but I can be equal right there. Yep. So what's the answer to that case? Just pi. Yep. And there is the answer to the question. That's a lot to digest, guys. A lot. We're gonna practice again tomorrow, so don't fret about it. But for now, let's turn to page 13 and you check your understanding. Now, on this page, it looks like they're all, or at least all the ones I'm looking at right now, are regular equations. So this should be easy for you. So what are you going to do here? You're solving an equation. Do not be overwhelmed. Be enthusiastic. We love learning. What are you going to do first?
So add the 5
Add the 5 and divide by 2. Absolutely. So it looks like cosine equals -1. Oh my gosh, what an easy problem. Where does cosine equal -1? Just pi. That's your only answer. Just pi. It's an equation, so we're not worried about intervals. We just want to know where does it equal pi. All right, number 2, you are going to need your calculator for, because it says that sine theta equals 0.75, which is 3/4. And 3/4 is not one of your like root 3/2 type numbers, right? So before you type it in, is that positive? Before you type it in, I want you to visualize where will the answers be. Quadrant 1 and quadrant 2. Now, I have no idea what this angle is, no idea at all, but my calculator does. Let's make sure I'm in radians. And how do I type that into my calculator? Guys, we gotta know this. Inverse sine. If you know the sine and you want the angle, you're using your arc sine. You're finding the angle whose sine is 0.75. So second sine 0.75. I got 0.848. So one angle, one answer is 0.848. That's this guy right here. The other answer is all the way around to here. You have to figure that out. Your calculator, well, it'll help you, but how are you going to figure out what that blue thing is? Well, if this little pink arc here is 0.848, isn't this guy 0.848?
Yeah.
Okay, and all the way to here is pi. So if I only want the blue part, won't I take pi minus 0.848? And the other answer then is 2.294. You with me on that? All right. Well, I'm handing back some papers. Would you solve this next one? It says find all of the x-intercepts, but what that means is set it equal to 0 and solve on the closed interval from 0 to pi.
Don't do it. Don't do it. Don't do it.
Okay, do we have an answer yet?
Oh, that hurts. Don't know where I was going.
Okay, everybody's got an answer. It looks like a bunch of you are just sitting around. Oh, guys, it's all figured out. So I'll stop handing things out for the time being. And let's catch up. All right, what did you do here? What'd you come up, let me just hear some answers first of all. What'd you come up with? X equals pi over 3? 2 pi over 3? When you square rooted, did you remember to do plus or minus? All the time. And not just in trigonometry, but every equation you ever solve in your life. If you are square rooting, if you are physically putting in the square root, then you've got to put plus or minus. Okay? So I am totally with you on those two, but I think you should also have 4 pi over 3 and 5 pi over 3. All the pi over 3s should be your answer. All right, let's try the Ferris wheel problem while I continue passing these out. Is that yours?
I mean, really, so what are we doing? Are we doing the fair stuff?
Take the back right
Do what?
here. Hey, are you having physical problem?
No, I understand.
Is that your paper back there? Back there by the plate. If it is, put your name on it, put it back in the plate. Yeah, it is. Put your name on it, put it back in the plate then. Okay, my friends. What kind of progress are you making with the Ferris wheel problem? What's going on here? Okay, what is this doing? Distance above the ground. So our ordered pairs are minutes and distance above ground. Okay, that's what ordered pairs represent. Every ride is 3 full revolutions. So a ride, you go buy your ticket, you pay your money, you get to go around 3 times. How many minutes does one ride last? What was your thought on that? Find a period, because isn't a revolution a period? So one revolution is the period, and the period is 2 pi, this is a cosine, 2 pi divided by pi over 4. Which is 8. So a ride, not a ride, but a period is 8. So a ride would be what? Is this minutes? So does one ride last 24 minutes? Yeah, because a full revolution, did I divide that right? Okay, so 24 minutes, 8 times 8, 3 8s, 3 times around. Takes us 8 minutes to get around. We're going around 3 times, okay. Find all the times at which Patty is exactly 40 feet above the ground. Well, how did you do that? You want Patty to be 40 feet above the ground, so we're at the 40 right here. So 40 equals negative 20 cosine pi over 4t plus 23. So let's subtract 23 and we get 17. And then what shall we do? Divide by negative 20. Everybody okay up to this point? All right, now, let's just step aside for a second. What if it said, what if you had the problem and it just said cosine x equals negative 17/20? How would you do that problem? If it said cosine x equals negative 17/20, what would you think about? Would you think about being over here and over here? And that is not like, if this were root 3 over 2 or something, we'd have it made in the shade, but it's 17/20, so I'm gonna need my calculator. Okay, so what am I gonna type in on my calculator? Second cosine?
Second cos.
All right, so second cosine. And that tells me that this guy right here, that angle right there, is 2.587. Is that what you got? So one of my x values, remember, I'm doing this problem right here. So one of my x values would be 2.587. Okay? Now, what's this one going to be? Ideas? Julia?
You just take 2 pi and subtract 2.587.
Okay, I think you're on target there. There's somebody, what you said threw me off a minute, but I think you know what you're talking about. This pink arc is 2.587. Would you agree this one right here is also the same? Isn't the blue thing that I'm looking for the entire circle except for this piece right here? So Julia's saying take 2 pi minus that, and we get 3.696. Would you agree with that? Now, those are the two answers. If I go around the circle one time, wait a second, this girl is she's got a ride on the Ferris wheel, so she is going around 3 times. So add 2 pi to both of these. That would be the second time around. So 2.587 plus 2 pi would be 8.870 and 3.696 plus 2 pi would be 9.979. Everybody okay so far? So there's the first time around. Here's the second time around. I need a third time, so what am I gonna do? Add another 2 pi. Add 2 pi around. So 16.262. We're not done yet, guys. I see some of you looking at me funny, and you should be. We're not done yet. But would you agree that those are the answers for this equation if I go around 3 times? Okay. Unfortunately, that was not my equation. This was my equation, right? But don't worry, we can salvage it. Because I let this be x. So now I'll take my 2.587 and set it equal to pi over 4t. And that's going to give me the t value for my actual equation. Would you agree with me? Okay, so here we go. So I'm going to times by 4 and divide by pi. And my first t value first actual t value is 3.294. And what would be the unit on that? Minutes? Okay. All right. What's my next one? Well, it would be this one times 4 divided by pi. I got 4.706. And I'm going to keep doing this for all of these answers, right? And that should be the answer to my question. I'm going to just check something. Times 4 divided by. The last one works out to be 20.75. Remember, when did the ride end? 24 minutes. I just did the last one to make sure it was in that interval. Okay, well that was fun and exciting. All right, let's get out our worksheet from last time. It's the one that had the box of fun stuff with a 3.1 problem on it. You finished that. Let's look at the next page real quick, see if we get one more problem done. Okay, so I'm on, I guess, the last page of this worksheet. little worksheet packet. The first problem, number 1, says sine theta is greater than or equal to √3/2, and we are between 0 and pi inclusive. Oh, no pi. 0 and 0. And we want to find all the values for which sine is bigger than √3/2. Now, you can do this however it flips your switch, guys. That is a pretty handy little number. You know where the sine is √3/2. Where is the sine √3/2? At pi/3 and 2pi/3? Right? Now, sine is y. Right here, this dashed line I drew, that's where the sine is exactly √3/2. If I want it to be more than √3/2, then isn't it going to be up here?
Interruption. Can you please have Patrick Mazer report to student services with his car keys at the end of the period?
Yep. Where are you parked, Patrick?
Thank you.
Why are you? Are you in the spot? So, we are going to be above that dashed line. So what am I going to write as my answer? Make sure your interval makes sense. What are you going to write? Bracket pi/3, comma, 2pi/3. And that's it. That's the answer. Those are the places where the sine is bigger than √3/2. All right, we'll do one more. I promise. This is it, number 2. Cosine less than 1/2. So if you're using your unit circle, which is perfectly okay, where is the cosine exactly 1/2? Pi/3 and 5pi/3. That's where the cosine is exactly 1/2. Now, cosine is x. So this is 1/2 right here. This is where x is 1/2. There and there. Now, where is it less than 1/2? Isn't all of this less than 1/2? Talking about x values. So what's your answer? Pi/3 to 5pi/3. And those would be open intervals because it was a plain less than symbol. Alright, well we're going to work some more on this tomorrow. I haven't officially assigned the homework yet.